Hello and welcome to Renewable Energy Technologies for Residences. This webinar was recorded on January 13, 2016 and is available on the Mass Clean Energy Center's YouTube channel. A link to a PDF to the slides for this presentation is available on that page as well. At the end of the presentation, there will be a number of links for more information about each of the technologies presented. And if you have any questions or comments, the emails to the presenters listed here will be found at the end of the presentation. For this presentation, we will be talking about thinking about your home, residential renewable energy technologies, including solar electric systems, solar hot water, biomass pellet central heating, air source heat pumps, ground source heat pumps, and then we will talk about next steps. A little bit about the Mass Clean Energy Center. We are a quasi-state agency that was created by an act of legislation, but we get our funding from the Renewable Energy Trust Fund, which is a systems benefit charge on ratepayer electric bills from investor-owned utilities as well as municipal light plant utilities that pay into the trust. And we're really focused on growing the clean energy economy in Massachusetts and accelerating the success of clean energy technologies, companies, and projects throughout the Commonwealth. Thinking about your home. So there are many reasons to invest in energy efficiency and renewable energy technologies. These could be saving money, making your home more comfortable, or helping the environment or reducing reliance on fossil fuels. There are many complementary solutions for your home. First and foremost is energy efficiency and conservation. We really see this as the low-hanging fruit that should be done first. You can ask for a free energy audit if you're in an investor-owned utility from MassSave, which you can find online or if you Google MassSave. And if you are in a municipal light plant territory, you can go to their webpage and learn more about getting a free energy audit. There is also renewable electricity, as well as hot water and clean heating and cooling technologies, some of which can be paired together, which we'll talk about a little later. This is an overview of all the technologies we're going to be talking about. We wanted to put one slide together that gave characteristics of each, what would be good characteristics for a home, but we will be going over all of these as part of this presentation. We'll start off with solar electric systems. So how do the solar electric systems work? What makes a good site? Current incentives that are available in Massachusetts, and next steps. How does the solar electric system work? Sunlight hits the solar panels and it's converted to what is called direct current electricity, or DC electricity. The electricity then goes down into what is called an inverter, where it is converted into AC electricity, or alternating current, which is used in your home. The electricity then goes into your electric panel and is consumed in the home. For investor-owned utilities, a net meter is installed. As you can see here in this particular picture, at times where the solar system is producing electricity but there is not much load in the house, excess generation will go through that net meter and out into the grid. That meter will spin backwards and excess generation will be credited to the account in a dollar amount to be used at a later time, such as in the evening or later in the month. For municipal light plant territory communities, speak with your municipal light plant power director and they will let you know about the metering that they have set up for solar electric systems. One question that we get very often is, if the electric grid goes down, will the solar PV system continue to operate? And the answer is no, not without a battery backup system. And the reason for this is that the utility requires that the inverter of the system shut down whenever the grid goes down. This is a safety feature to prevent islanding, in which potentially excess generation may go onto the grid, excess electricity, and cause a hazard for workers working on the lines. So it's generally not a storm ride-through technology. Oftentimes, for those handful of days where you may not have power, we recommend potentially getting a gas generator or something like that. What makes a good site? Southern exposure is ideal, as well as having the panels pitch around 30 to 45 degrees. You will want to have at least 4 to 6 hours a day of direct sunlight. because the sun is really what makes the solar panels operate. So you want a very sunny site. You also want open roof space, about 100 square feet per kilowatt. In Massachusetts, the average size system is around 6 kilowatts. So looking at about 600 square feet around there. Owning the roof is ideal. It can make the contracting process a lot simpler. You want to have an electric bill that allows for a solar system to make economic sense. The bigger the system, oftentimes the cost per unit is lower. A very, very small system may be much more expensive, but definitely get multiple bids. I'm kind of jumping ahead of myself here. What to do with a non-feasible site? There are definitely other renewable energy technologies, which we'll be talking about shortly, as well as doing energy efficiency as well. Community shared solar may be another option. Massachusetts has some of the highest electricity prices in the nation. As of, I believe, 3 years ago, we were 9th in the nation for our electricity prices. We've also seen the cost of solar reduce greatly over the past 5 years. There are also a number of incentives in the state, which makes solar PV fairly economical projects. I'm going to give a basic overview of the incentives. Please note that there's a lot more information on our website, as well as a residential guide that we have available. So I'm going to go over the basics of these, but please learn more online. There is a state and federal tax incentive. The federal tax incentive is valued at 30% the total cost of the solar electric system. The state tax incentive is valued at 15% of the total cost of the system, but it is capped at $1,000. We talked a little bit about net metering. If you are in a municipal light plant territory, again, speak with your energy operator to determine what kind of metering you have. SREC sales, solar renewable energy certificates, are another means of monetizing the electricity. The Mass Solar Loan Program is a program that was recently launched in December. It is a partnership between the Department of Energy Resources and the Mass Clean Energy Center. And the program is really focused on helping provide low-interest loans for residences that are looking to purchase their system, and also offers additional incentives for low and moderate income households. There may also be lower no money down options. This is where a third party may own the system and maintain it, but may not have any additional cost for you at the front end, but you pay a reduced electric bill over the life of the system. So for next steps, if you're interested in learning more about solar electric systems, also known as solar photovoltaics or solar PV, you can go to our website. We have a page on learning about solar electricity. We also have a residential guide to solar power. It is a PDF on our website. To find an installer, we do have a web page that offers a number of resources about what to look for. We recommend getting 3 price quotes or more just to understand what different options are out there. And also consider participating in the Mass Solar Loan Program. The next step, once you contract, is the installer will complete the design and install the system. Then you would apply for the SREC program, federal and state incentives. Now I will turn it over to my colleague, Josh Kessler. Josh?
Thanks, Elizabeth. Originally, MassCEC was focused primarily on electricity-oriented technologies, but heating actually represents the largest use of energy in Massachusetts after transportation. And there's a major opportunity right now to transform our heating infrastructure to a much cleaner infrastructure. In terms of residential heating, about half the homes in Massachusetts use natural gas, which is relatively clean and very affordable at current prices. On the other hand, most other homes use fuel oil, electric resistance, or propane, or occasionally even wood. These are more expensive and much higher polluting fuels. And many homes are located in areas with limited access to natural gas, so the clean heating and cooling technologies we're about to discuss can be a great option for homeowners in these areas. On the last slide, we focus primarily on heating because that's the largest portion of a typical homeowner's energy cost. Some of the technologies we're going to discuss in this video are also useful for hot water and cooling as well. When thinking about a heating and cooling technology, it's important to understand the traditional alternatives you're comparing them to. Traditionally, most heating and hot water systems have run on natural gas, fuel oil, or electricity, whereas cooling systems run primarily on electricity. The clean alternatives we're discussing here include solar hot water systems, air source heat pumps, ground source heat pumps, and wood pellet heaters, also known as biomass pellet boilers. Now, air source and ground source heat pumps, as well as pellet boilers, are primarily used for heating. Both types of heat pumps can also be used for cooling. And finally, solar hot water, ground source heat pumps, and pellet boilers can all be used for hot water heating. In terms of the energy savings and the associated reductions in greenhouse gas emissions, ground source heat pumps have very high energy savings compared to other heating technologies. And of course, solar hot water is entirely emissions-free. Both of these technologies come at a cost, though. On the other hand, air source heat pumps offer somewhat more moderate emission savings, especially compared to oil and electric resistance. They do still offer significant savings, but the installation cost is much lower. Now, with wood pellets, they generally have moderate emissions reductions, as well as a more moderate installation cost. Now I am going to turn it over to Meg Howard to discuss some of these specific technologies.
Thanks, Josh. I'm going to start by talking about solar hot water. How do solar hot water systems work? Unlike photovoltaic systems, which Elizabeth talked about, solar hot water systems don't generate electricity. They work by circulating a fluid up to a collector that then gets heated up and brings that solar energy, usually to heat up water, although it can be used for space heating. We are primarily talking about a hot water renewable technology here. These systems can provide 50 to 80% of a home's annual hot water needs. We've rebated hundreds of these systems at MassCEC for residences and dozens more for businesses and institutions. To have a good site for solar hot water, you need space available for the collectors. They take up less space than a photovoltaic system, so they can be a good alternative if you don't have enough room for photovoltaics, but they still do require about 50 square feet on your roof, or else space available for a ground or pole-mounted system. You also need space available in your mechanical or boiler room for a solar hot water storage tank. We recommend that your roof site or ground site faces south. East or west can work, but south is best. And while these solar hot water systems are more tolerant of shade than photovoltaics, the collector site should still get about 4 to 6 hours of direct sunlight per day. There's lots of incentives for solar hot water in Massachusetts, starting with our own rebate from the Massachusetts Clean Energy Center. We offer up to $4,500 for a residential solar hot water system, and that rebate is currently approved through the end of this year, 2016. There's also a federal tax credit, which covers 30% of the system cost, and that tax credit was just extended through 2019 and then at slightly declining rates through 2022. The utilities offer the MassSave Heat Loan, which is a great deal. It's 0% financing for up to 7 years to help cover the rest of the cost. And the state is also working on alternative energy credits that could help finance solar hot water systems. So those details will be announced in the coming months. And finally, solar hot water systems are tax exempt from Massachusetts sales tax. Another renewable home heating solution to consider is biomass pellet central heating. How do these systems work? They work pretty similarly to an oil system in a way. It starts where a wood pellet delivery truck would pull up outside of your home, much like an oil delivery truck, and then that fuel, in this case wood pellets, would be automatically fed into a built-in storage area in your home, and then from there they're automatically fed into a biomass boiler. So it's all automated, nothing like where you're feeding logs into a boiler. And that boiler modulates automatically in response to your thermostat, heats up hot water that then can be distributed throughout your home for space heating and for hot water. What makes a good biomass site? These work best in homes that do have hot water heating distribution systems, although there are starting to be some limited furnace options available. You would also need room in your boiler or mechanical room for the boiler or furnace itself, the thermal storage tank, and the area where you'd be storing the pellets. These systems have the best payback compared to electric resistance, oil, or propane heating. In terms of incentives, Mass Clean Energy Center offers up to $12,000 for residential biomass central heating. These systems are also eligible for the MassSave heat loan I just mentioned, 0% financing for up to 7 years, and may get some alternative energy credits when those are finalized. Another heating option to consider are air source heat pumps. Air source heat pumps work by moving thermal energy from an outdoor location to an indoor location. Because they're just moving the thermal energy instead of creating it, like electric resistance heating does, they can be 2 to 3 times more efficient than electric resistance heating. And they can alternate modes, so they can provide heating in the winter, cooling in the summer. And there's been recent improvements in these technologies, so they now do perform better in cold climates like Massachusetts and can really provide heating year-round, even down to the cold temperatures we get here. These technologies can be employed almost anywhere. You do need some outdoor space available for the units, like the ones you saw on the previous slide. And usually those outdoor units would need to be mounted above the snow line. And then you would need indoor wall space, typically for a wall-mounted unit, although there are a couple other indoor unit configurations available. These air source heat pumps can be a great solution for homes that don't have ductwork but are looking for modern cooling solutions or heating solutions. Again, we see the best payback for homes that currently have electric resistance, oil or propane heating. Another great flexibility of these systems is that they can provide supplemental heat to one room or a zone of a house, as well as doing the whole home. We do recommend that if you are heating your whole home with air source heat pumps without any backup heat, your home should be well insulated and very energy efficient. And finally, one last perk is that these systems are typically less noisy than a traditional heating or air conditioning system. Mass Clean Energy Center offers $625 to $2,500 rebates, depending on what kind of heat pumps you install. And they also get rebates from the utilities up to $500 and are also eligible for the MassSave heat loan. I'm now going to turn it over to my colleague Josh again to talk about ground source heat pumps.
Thanks, Meg. So I'm going to talk to you about ground source heat pumps now. Ground source heat pumps, also known as geothermal heat pumps, operate by extracting heat from the ground, as the name suggests. The system operates by circulating cold water into a plastic pipe that often extends hundreds of feet into the ground. This works because no matter how cold it is on the surface, underground temperatures remain around 50 degrees year-round in this part of the country. Now, there are two main types of ground source heat pump configurations. First, and the most common type of system, is a closed-loop system, which pumps a mixture of water and antifreeze into the pipes so that it doesn't freeze. The water then goes through the ground and then comes back up a loop into the heat pump again. As the water travels through the ground, it's heated back up so that the water captures the temperature from the ground. Now, open-loop systems operate in a similar way, but instead of just pumping water through the pipes, they actually exchange water directly with an underground well or aquifer, then return water that's much closer to the actual ground temperature. Now, when the water enters the pipe, it extracts heat from the through a compression process, much like in an air source heat pump. The heat is then extracted by the ground source heat pump and distributed throughout the house, usually using a forced air system, although baseboard and radiant systems are possible as well. This process is very efficient, and ground source heat pumps can transfer as much as 4 to 5 times as much energy from the ground as they require to operate. Now, what makes a good ground source heat pump site? The first consideration is whether there's available space. All heat pumps require a certain amount of indoor space, usually in the basement, although it's relatively moderate. Now, vertical loop systems require a relatively small footprint, Typically, there are 1 to 3 wells or boreholes, which are located about 20 to 30 feet from the house, although that can vary. On the other hand, whereas a standard vertical loop system requires a borehole that's 700 or several hundred feet deep, a horizontal loop system sits in a trench. The trench is cheaper to dig since it doesn't require any special drilling equipment. However, it does require a large footprint, with trenches often spanning as much as 100 to 150 feet in length. An open loop system requires an underground well or aquifer, and these systems tend to be even more efficient than closed loop systems. However, they can only be built on certain sites where you have access to that well or aquifer. Now, who should consider owning a ground source heat pump system? Really, any owner looking for the highest emissions reductions of any heating and cooling system, but who, of course, can afford the high upfront installation costs. Now, these costs are somewhat offset by a combination of MassCEC and other incentives, as well as the long-term energy savings that can be achieved by the system. As with other heating and cooling systems, ground source heat pumps provide the best payback versus electric resistance, oil, or propane heating. And then, of course, the final issue to consider is that these are very complex systems, and finding a good installer who will provide a high-quality design and installation is absolutely vital. Now, to talk through the incentives available, first, MassCEC offers a rebate of up to $12,500. There is a federal tax credit that is currently available for 30% of system costs. MassSave, the utility program, offers a heat loan of 0% for up to 7 years, up to $25,000 worth. There are forthcoming regulations related to the alternative portfolio standard, whereby system owners will be able to get what's called alternative energy credits for the production of their systems. And finally, these are exempt from the Massachusetts sales tax. Now, in terms of next steps for people looking to install clean heating and cooling systems, we certainly recommend that you take a look at our website, www.masscec.com, to learn more about the technology. And take a look at which technology really fits your needs and your budget. The next step is to find an installer. And as with solar, we recommend that you solicit at least 3 price quotes from different installers. Make sure that the installer is qualified by checking their references for similar projects and ensuring that they have the relevant accreditations and or manufacturer training as described on our website. And finally, the installer will apply for the incentive on your behalf and hopefully will help you find financing in order to install the system. And last but not least, enjoy the savings from your new clean energy system. In terms of combining technologies, there are certain technologies that work very well together. First off, solar electric and solar hot water can really be designed and installed at the same time. As you can see on the roof below, this is primarily a photovoltaic system with a smaller solar hot water system as well. Now, solar electric and heat pumps also work very well together. And one way to look at this is really heat pumps rely on electricity, whereas traditional heating systems rely on fossil fuels. And if we're ever going to fully decarbonize the grid, we will need to rely on solar or other renewable emissions-free technologies. And that makes solar and heat pumps an excellent combination. Finally, solar hot water and biomass systems pair well together. Solar hot water system really can complement a biomass heating system by providing hot water in the summer and preheating water in the winter. Now, below, please take a look at these technology-specific links for each of the technologies that we discussed. We also provide information on tax credits, the heat loan, and the upcoming alternative energy credits that will be available to help finance your system. So thank you for taking the time to watch this video. We hope you found it informative, and we hope that you come back for more.